Last lecture, we made it. It's been kind of a crazy term. I'm glad you guys all stuck with me, and I really hope that you guys have enjoyed the class, enjoyed the material. I'm so passionate about this type of work and about the brain in general. And I hope that some of that may have rubbed off with some of you. I know that a lot of you aren't really going into this field and that you may be pursuing something clinical or something like that. But I hope that some piece of this can kind of help facilitate whatever your goals or your careers are. So today we're going to talk about a really cool topic that I'm glad I didn't have to cancel. I've been really excited about this topic because it really kind of ties up everything that we've been talking about. And it's something that's really still a mystery, something that we haven't really gotten super far with yet. And so as we go through this, I'll kind of give you some evidence of what we found that has kind of constrained what we're able to say about consciousness. But by the end of it, you can kind of decide for yourself and really think through it and think about what it may be to you. So today we're going to talk about consciousness and about some of the work that's gone in to try to really narrow down what it is. And it's something that's really hard to define. And we kind of talked about that with emotion. Emotion itself was something that was really hard to find, and that kind of influenced the way that the work was done. So we're going to start with kind of describing what the mind-brain problem is and what makes this really difficult. And how that's kind of contributed to the way that the researchers are trying to define it. We're going to look at some of the brain regions that have been proposed as sort of seats of consciousness. You got to keep in mind that there's not one brain region, or else we would have found it by now. But we'll look at some of the brain regions that we believe are probably involved because of what happens when they're damaged and when stuff goes wrong. We're going to look at complex systems. So the brain itself is a complex system. It has many interacting parts. There's sort of this emergent property of consciousness that arises out of it that can't really be explained by studying the individual parts. So we'll kind of look at how all that works. And then near the end, we'll look at what kind of information we actually have access to and how that kind of influences the way that consciousness works. So let's dive in. This is something I've been really excited about, something that I alluded to on the very first day of class. If you were to look at the Earth and how small the Earth is in this galaxy, right, this tiny little dot here, that's kind of what we're looking at when we think about consciousness. It's something that doesn't really have access to vast amounts of information. I mean, that whole intro I did at the very beginning of class was really demonstrating that there are millions and millions of interactions happening in your body at every given moment of every day that your conscious experience, your conscious awareness doesn't have access to. It only receives the information that's important and the information that needs to be kind of addressed to be able to guide the overall behavior of your body. And consciousness itself is really kind of the holy grail of cognitive neuroscience. It's what we really want to achieve. And there's a lot of people that don't think it's possible for us to understand consciousness. And we'll get into why that might be the case. So we're going to start with the mind-brain problem. And it's this idea of how is it that a purely physical system, something that's made of atoms and electrons, something that if you study physics should be very predictable, very cause and effect when these neurons, or when these kind of atoms and electrons interact with these atoms and electrons, they should do the same thing every time. So how is it that we have this conscious experience, this perceptual stream, when it's all kind of made out of this purely physical system? And so we talked on the first day about dualism. This was something that was proposed by Descartes a long time ago. In which he stated that there was a mind that was separate from the body, or kind of a soul that was separate from the body. And the body itself was just sort of a machine that could be kind of controlled. And so you really didn't have to understand the physical properties at all, because the mind itself wasn't part of those physical properties. It was something separate, something kind of metaphysical. And that was a very popular idea for hundreds of years. I mean, it was something that really drove a lot of the Christian type thinking and things like that. But a lot of scientists these days are really kind of moving forward with this type of materialistic view of just kind of the mind-brain problem in general, of arguing that that thoughts, that the mind itself is also kind of physical in nature. And that if we understand the brain well enough, if we understand how all of those interactions are happening, that we can completely predict how the mind should work, and we can predict what types of thoughts will arise and what consciousness is. These are vastly opposed to one another. It's saying that the mind itself is not special and not separate from the body, but is just kind of created by the body and is part of it. But there's this really important gap that we need to kind of bridge, because dualism tends to kind of ignore the physical stuff of like, I don't need to understand the body because the mind is separate. But materialism also kind of does the same thing in the opposite direction. It focuses really, really heavily on the physical stuff and tends to kind of ignore subjective experience and how kind of emergent that subjective experience is. And there's a lot of philosophers that are really trying to kind of address this gap in the mind-brain problem, and proposing kind of some more naturalistic ways or so to kind of come about it. We won't get too heavy into that philosophy because we're going to get more into the brain stuff, but this is a very heavily pursued topic in the philosophical literature of trying to understand how neuronal activity equals subjective experience. And so this really kind of falls in line with a lot of what we were talking about with emotion, about how it's really hard to define what a feeling is and what it's made of and all of those things. And the same thing kind of happens with consciousness. There's a lot of different definitions that have arisen from researchers throughout the past hundreds of years or whatever. And a lot of them were kind of centered around the human being somewhat special, and that consciousness was something that only we had, and that it was linked to our ability to recognize ourselves in the mirror, right? The sense of self-awareness, that was consciousness, and that only humans had it. There were some people that argued that consciousness is actually a new phenomenon, and that our older ancestors, even though they were human, didn't have the level of consciousness that we had. And a lot of those ideas have really fallen flat with newer researchers. There was this really good quote from Steven Pinker I wanted to read. So he said, something about the topic of consciousness makes people, like the White Queen in Through the Looking Glass, believe 6 impossible things before breakfast. Could most animals really be unconscious? Sleepwalkers, zombies, automata, out cold, right? Are these animals, are they not feeling anything? Hath not a dog's senses, affections, or passions? If you've ever experienced a time with a dog, if you've ever had a dog, you realize that they have a very complex emotional world, right? And if you prick them, do they not feel pain? A dog feels pain. Almost any animal you interact with feels pain. They know what it's like to feel alive. And was Moses really unable to taste salt or see red or enjoy sex? And so this is kind of in the face of these people that think that consciousness is some new thing that has evolved because of like cultural adaptations and things like that. Do we really believe that our human ancestors didn't experience the same type of perceptual richness that we have? And do children learn to become conscious in the same way that they learn to wear baseball caps turned around? Is this something that we get better at? It's really hard to kind of put it in that perspective, because it feels like we're conscious from the moment that we're born, the moment we first open our eyes. It's just this feeling of being alive. And so he says people who write about consciousness are not crazy. These are smart people that are coming up with these ideas. So they must have something different in mind when they use the word. It really kind of, Steven Pinker is a very kind of new philosopher in the world of this type of problem. And it's really starting to address some of those problems and how they're falling flat when we really look at the conscious experience of animals and things like that. And then Stuart Sutherland took it one step further and said, nothing worth reading has ever even been written about it. That's how little we know about consciousness. He said, consciousness is the having of perceptions, thoughts, and feelings, right? It's this being aware that we're alive. The term is impossible to define except in terms that are unintelligible without grasp of what consciousness means, right? It's trying to get at this idea that words don't really describe what consciousness is. And many fall into the trap of equating consciousness with self-consciousness. But to be conscious is only necessary to be aware of the external world. And so this kind of went in the face of those people that thought that like self-awareness was consciousness. But he's arguing, no, it's just having to be aware of the external world. What he was getting at, he said, it's impossible to specify what it is, what it does, or why it evolved. Nothing worth reading has ever been written on it. And it's just this idea that people don't really know what consciousness is. So there's a lot of people that have tried, but it just seems like something that's so impossible to really tackle. So he was arguing that we can have complex thoughts, we can have mundane worries, and that those can be associated with feelings. And even though we're aware of these contents, consciousness does not entail that we have to be aware that we are aware. It's just kind of a feeling of being alive, right? So this idea of self-knowledge being something special, of self-awareness being something special, kind of falls flat with a lot of these newer philosophers that have really tried to tackle this idea. And they say that the knowledge that we have about ourselves is just another type of knowledge that we have access to. There's nothing special about it. It's just a new kind of process that more evolved brains have adapted. It's not saying that other animals are not conscious because they're not self-aware. They're still aware. They're still alive. There was a really, really cool quote that I came across a long time ago. I think it was from the Upanishads, kind of this ancient Indian text that said the first being that ever became alive was immediately afraid. And I always really loved that quote because it really kind of tied into this idea that if we know we're alive, we know we don't want to not be alive. That there's this inherent fear in losing that awareness and losing that feeling of being alive. And so a lot of these people are just arguing that it's just that sentient feeling. It's not necessarily these complex cognitive processes, but it's just this awareness that we're alive and that we're feeling things. And it's something you have to experience in order to define. Like that's what Sutherland was trying to get at, was that like words fall flat a lot of the time when we're trying to explain things like this. Try to explain nausea to someone that's never experienced it before. If you've ever been in a doctor's office, it's really hard to try to tell them what you're feeling, you know? So a lot of what consciousness really is about is the information that we are aware of, the access of information that we have. And we can only report on things that we have access to, that the conscious portion of the mind has access to. But we don't have access to how all of that content was built, how the neurons and the neurotransmitters and all of the other things in the system, we don't really have any insight or any intuition about how those things are working unless you've taken this class. But even when you have, you really don't think about those things. You're just aware of what all of those processes have created and what kind of information they're passing to you as the conscious observer. So conscious processing kind of involves everything related to things that we can actually verbally report on, things that we can actually subjectively talk about, rational thought, right? Being able to deliberately make decisions and all of the output from all of the processing systems that we've talked about in this class, about the stuff that comes out of memory, the stuff that comes out of our attention processes. Those things that have made it all the way to the top of this really complex system are the only things that consciousness can really report on and can really engage in. Whereas non-conscious processing involves so much other stuff. So all of this autonomic gut level type stuff. And like, this is kind of ignoring the fact that there's all the homeostatic stuff that's going on, all of these really complex interactions between billions of your cells, not just neurons, but skin cells and muscle cells, all of this stuff all together that we don't have awareness of. That's not part of our conscious experience. Like when you really look at this, it is like this iceberg that Freud tried to describe a long time ago. But I would argue that the tip of this iceberg, the very tip top, is what consciousness is. Like this is showing way too much. We don't have access to so much of what's going on. And when we think about our experience as an agent, as a conscious agent, that experience is explained by a couple of different terms. So we're going to look at Qualia and this idea of what an Umvelt is. Oops, that's supposed to be a W, Umvelt. It's a German word. So Qualia is kind of a philosophical term that gets into sentient experiences, individual sentient experiences. So in the moment, what does it feel like to be you right now? And if you and another person are looking at the same thing, the same color, or the same sunset, are you having the same experience? Does it feel in that moment like you're having the same experience? The Umvelt is a little bit more broad. It's kind of the overall experience of what it feels like to be you or to be something else. So Qualia is getting at like individual moments. Umvelt is kind of all of those individual moments put together. So what would it feel like to actually be a bat, right? And not just what would it feel like to be a bat, but what would it feel like for me to be a bat? It would be a completely different experience. Something that I brought up at the very beginning of this class was my sister, something that really drove me to get into brain science in the first place. She's got cerebral palsy. She's got a whole host of other cognitive deficits that she deals with. And she experiences the world in a completely different way than I do. And it's really hard to put myself into her perspective. But everything that happens to her, everything that she feels, everything that she thinks about feels normal to her because that's all she's ever known. So someone's Umwelt is really all encompassing, and it feels natural. It feels right because that's how you're supposed to be. When you're a bat, you're used to being blind. You're used to using echolocation and all these things. You're used to flying through the air blind and catching insects in midair because that's just the way life is. That's your experience, your sentient experience. Really interesting kind of thought experiment to really try to go through this and try to think these things out. So Qualia, individual sentient experiences. Umwelt, kind of more of the overall, what it feels like to be that organism. So, and this all kind of comes back to, this is very similar. They call it the hard problem, the mind-brain problem. It's like, how do these neurons that are firing actually create that sentience experience, create the qualia or the Umwelt, the overall experience of the organism? And you really got to think about this in a really strict way, because these neurons, they're in different locations in physical space, and there's billions of them, right? And there's different clusters of neurons that are processing different kinds of information. And how is it that all of these things that are separate from one another in physical space, when they're all firing together in some coordinated pattern, how does that ultimately create this emergent property of what it feels like to be conscious, to have this perceptual stream of awareness? We don't know. Some think it'll never be solved. That it's not something that can be studied with the current tools that we have. Daniel Dennett went as far as to say that consciousness is an illusion, and like other optical illusions, we fall for it every time. I don't know if I fall into Dennett's boat here, but he's really talking about how difficult this whole problem is to try to be solved, and that it's kind of this idea that, like, oh, you know what, it's probably just this illusion, and that there's really nothing to it at all. But we'll get into some ideas about how people think this might work. And one of them was the global workspace theory. This is a little bit complicated, and I don't have time to really dive deep into it. There's a lot of work that these people have put into this. But it's talking about consciousness as being this thing that allows different networks to cooperate and compete with one another to solve overall problems that the organism is addressing. And so in that moment, that really brief moment, every moment of every day, there's some sort of retrieval that's happening that's allowing the organism to make quick decisions for the overall health and well-being of the entire organism. They call target retrieval. So it's a lot like working memory, but it's much more fleeting. It's something that's happening every single moment, right? And this was Edelman and Tononi were big proponents of this global workspace theory. And they really think that the lamocortical system is what's really giving rise to consciousness, because it's this interactive kind of reciprocal feedback system. There's constantly information coming back and forth between the thalamus and the cortex that's really allowing all of these things to progress. And it's something that we've talked about when we talked about attention and motion and all of these different things, that the cortex and the old brain are really kind of working together in these feedback loops. And they think that that's really what's kind of giving rise to conscious experience. And Stanislaw Dehaene kind of added to this idea, kind of adhered to this global workspace idea, and suggested that in order for information to become conscious, it has to be kind of represented as the focus of top-down attention. So the spotlight of attention has to kind of hit whatever information the organism is interested in. And the attention mechanisms will then amplify the neural firings of whatever. So if it's you're attending to this lecture right now, right? You are boosting the neural populations that are representing the sound of my voice right now. And because of that, all of that information is kind of online and coherent right now. And it's all becoming conscious. The global availability of that information, because it's been boosted by these attention mechanisms, kind of rises to the surface and becomes conscious. And it involves tons of neurons that are kind of distributed throughout the brain, right, in different locations in space. And so they're arguing that it's all of these neurons kind of firing in sync with one another creates this kind of network emergent property. And that attention is really what's driving the connection between these different networks. So when we really look at this from the cognitive neuroscience approach of like, how do we solve the consciousness problem with the tools that we have in cognitive neuroscience? Researchers have kind of broken it down into these three categories. So consciousness involves the contents of conscious experience, right? So this is what our perceptual streams, processing streams are actually coming up with when they process all the sensory information that's coming in. It has to do with how we have access to that information. So there are some disorders and lesions and things that even though things are being processed, we don't necessarily have access to them. So consciousness has to have access to whatever information it's relying on. And the last piece of that is the sentient part of it, what it actually feels like to access that information and to experience that information. And what we've kind of discovered as we've gone through this class is that we know a lot about the contents. We know a lot about how these perceptual processing streams work, how the medial temporal lobe and memory works and all of these things. We know a lot about access to information because of what I was just talking about with like lesion patients and things like that. We know what information we have access to and what information we don't have access to. But what's really hard is bridging the gap between these two and sentience. How is it that the creation of these perceptions and the access to these perceptions kind of creates this subjective feeling of being alive, this idea of sentience? And that's something that's really, really difficult to solve with what we have right now at our fingertips. It could be different in the future after Elon Musk makes his wizard hat. I don't know. We'll see. This is going to be something that I think researchers are going to be working on for a really long time. And I think they're definitely going to constrain the theories, but it's going to be really hard to definitively say what this is in one way or another. And so a lot of people have kind of proposed, they've gotten away from this idea that humans are special, that we're the only ones that are conscious. And have talked about how the consciousness of humans is just different. It's more detailed and more kind of extended. And so when you look at core consciousness, that's just the idea of being aware, kind of what we've talked about so far, of just being alive, being sentient, kind of interacting with the external world. So the organism's alive, it's awake, it's alert and aware of one moment, the right here and now, the place that they're in, right? There's no concern about the future. There's no concern about the past. That's not the kind of processing that's happening. It's just being awake and understanding that stimuli is hitting your sensory regions and being turned into perceptions and that you are aware of those perceptions. But extended consciousness kind of builds on that. It takes the current moment and it adds in all of these different flavors of things from the past and goals about the future. All of these different systems that we've talked about through this whole class that really add up to create the subjective feeling and what it is and how those influence the emotional state and everything like that. Extended consciousness is really believed to be kind of provided by the cortex, that the cortex is taking a lot of this just simple awareness type information and expanding on it and making sense of it. And we have access to a lot more information because of that, because of how much has been processed in comparison to simpler organisms. So core consciousness is just the idea that we're aware, that we're awake, extended consciousness is kind of building on that experience and bringing in the past and the future, the goals and the intentions and all of those kind of things that really make us who we are as humans and kind of set us apart from the animal world. So we'll look now at some of the candidates that have kind of been proposed as brain mechanisms. I'm going to check on my recording real quick and just make sure that it's still going. Cool. All right. So with the brain, we've really kind of narrowed down what regions are probably the best candidates. And those are probably the ones that are in these like older evolutionary places, because simpler animals are conscious. That's kind of what we've come to throughout this discussion that we've had so far. And so we probably share neural circuitry in these older brain mechanisms that kind of allow for that conscious experience. And so a lot of people think that the brainstem is a big part of this. Its primary job is kind of homeostatic regulation, which deals a lot with kind of the being alive and feeling alive. A lot of it's kind of handled by the medulla oblongata. Alligators are ornery because they have all them teeth and no toothbrush. But what happens when you kind of disconnect these, if you were to get a lesion here in the medulla oblongata or in the brainstem in general, the body and consciousness die. So if we have a lesion here, if we have a lesion here, somewhere in the thalamus, whatever, in the cerebellum, if we can have an entire cerebellum missing, there's people that found out when they were like 30 that they were missing a cerebellum. They're still conscious. But as soon as the brainstem gets severed, all of that disappears, according to what we have. That could be wrong, but that's kind of what we've seen so far. So the brainstem itself deals with all of the information coming in and all of the information going out. It kind of has everything all kind of packed in one place. And it's something that all animals kind of share. And so it seems to be a really good candidate for kind of the emergent property of what it feels like to be alive. And so in concert with the brainstem, the thalamus, and the cortex, they kind of maintain this level of wakefulness and they direct selective attention. But those things can still kind of go haywire and that the person or the animal still feels alive. And so cortex will expand the contents of what the organism is conscious of, but is not necessary. That's kind of what I was getting at, is that it seems like the brainstem is necessary for consciousness, according to what we have right now. That could be incredibly false, but it's that the cortex kind of expands on the contents of that, like we were talking about. And a lot of this comes from these patients that we've seen that are in big car accidents or things like that, where you can have a level of wakefulness is entirely necessary to be conscious, because when we're asleep, we're not conscious, right? But consciousness is not necessary for wakefulness. And we see that from people that are in a vegetative state, right? That they can be awakened, their eyes will open, they'll still just be laying there, but all we can get from them is reflex behavior. There's nothing kind of intentional about it. There's no kind of indication that they're responding to our prompts or processing our prompts. In contrast to that, there are people that are minimally conscious that show that they have localization of pain. So if you hit them in a certain spot, there's indication that they feel that pain. And there is some non-reflex movement that's like intentional. So they can fixate on a stimulus, or they can squeeze someone's hand when they're asked to. So this gives us an idea that they're really paying attention to and trying to interact with the things in their environment. And we think that that's really important for consciousness. And then what makes things really difficult is what's called locked-in syndrome. And this is something that is a new discovery that's really, really cool. So, I mean, it's not cool to be in a locked-in state. It's cool how they found it. Don't take that the wrong way. But it really complicates being able to diagnose someone as being in a vegetative state. And so someone can be completely unable to move, but be fully conscious. They'll go through entire kind of sleep and wake cycles. They'll be aware of everything that's going on around them, but they have absolutely no way of telling the outside world that they are conscious. Sometimes you'll see that they'll be able to blink an eyelid voluntarily, or make some kind of vertical eye movements, but for the most part, a ton of them don't show any signs at all. And during that time, a lot of these patients have gone under extreme medical procedures. And at the time, they believed that these people weren't conscious. And so they didn't even put them under anesthesia. Just insane. They've heard conversations about their fate, about whether or not they're going to be unplugged from their family members and things like that. And they weren't able to participate. They weren't even able to indicate to those people that they knew what was going on. And a lot of this, the reason I have this picture up here, is caused by a lesion to the pons, which kind of connects the cerebellum to the rest of the body. And it cuts off this ability to make any kind of outward external motion. And the reason that they discovered this, that they discovered that these people were conscious, came from these fMRI studies. So the first one was this woman that had been in a car crash, and she was diagnosed as being in a vegetative state, this unresponsive state. And so they put her in an MRI and they measured her brain while she was listening to spoken sentences. And her brain activity was just like that of healthy controls. It was amazing to these researchers. They're like, whoa, her brain is actually processing this in the same way that normal people process this. They even gave her kind of ambiguous words, and that was bringing up the same regions as healthy controls. But it still kind of begged this question of, was this evidence that they were actually conscious? Or is it just that these brain regions can still kind of process that information without us having actual access to it, actual conscious awareness of it? And so they took this one step further. Really, really cool. So they introduced an imagination task. And so they told the people to either imagine that they were playing tennis or imagine that they were navigating their house and going through the rooms in their house. And these patients that were believed to be in a complete vegetative state, when they were asked to imagine playing tennis, the supplementary motor area started to light up. Same area that healthy controls light up when they're thinking about doing motor tasks. That was the idea, that if you're playing tennis, you're thinking about initiating these motor movements. And so you have the supplemental motor area that's coming online. That's what we see here in this left panel. And when they're told to imagine visiting various rooms in their house, you saw perihippocampal gyrus activity. So this is like the place area that we've talked about in the ventral stream that is active when you're thinking about different places that you've been to and visited. Amazing finding that these people were just completely unresponsive on the outside, but they were still reacting and they were still participating in this study. Really cool. And so this was just this last note that this was the same. So these are the controls down here, the same brain regions when they're imagining things, not just passively listening to sentences, but actively imagining doing something. So they went on and they did this study with 54 other patients that were considered to be in a vegetative state. 5 of those 54 ended up showing the similar activity. So this wasn't evidence that vegetative state people in general were all locked in. There are a lot of people that are in a vegetative state that we still believe are not consciously aware and are not. But when those people did this, there wasn't the same activity. But 5 people out of this 54 showed that they were still conscious, that they were still aware. And they went even further with one of these, and they tried to use this as a way for them to answer yes/no questions. And so if they were going to say yes, they had them imagine a motor task like playing tennis. And if they were going to say no, they had them imagine doing a spatial task like walking through their house and looking at all the rooms. And you can see that it was successful. They were able to accurately, is your father's name Alexander? Yes. He was via the motor imagery. Is your father's name Thomas? No. Perihippocampal gyrus. Crazy. Do you have any brothers? Yes. Do you have any sisters? No. Really, really cool implementation of fMRI. If this doesn't fascinate you, like, I'm sorry if I'm going overboard, but I think that this is absolutely amazing. And it really brought up a lot of ethical concerns with these patients. Some of these people have actually recovered and have come out of the locked-in syndrome and are able to verbally report on this stuff. If you're interested, I totally encourage you to look into this a little bit more. It's really, really interesting work. So we'll look at a couple of the other systems that are believed to be involved in this. So the reticular activating system is what really regulates a lot of our arousal level, gets us awake, because being awake is something that's important for conscious experience. And it kind of modulates attention too. It modulates our sleep-wake levels. It has a dorsal path that goes from the thalamus to the cortex. And if you damage that one, then you have awake and non-responsive patients. So they're just like constantly awake. And if you damage the ventral path that goes from the hypothalamus to the forebrain, these patients are not able to stay awake. So it really shows that there's this really strict kind of wake and sleep state activity that's being controlled here that can cause some really devastating things to happen when those things are damaged. You have the suprachiasmatic nucleus, which is our biological clock. It's something that's in the hypothalamus. And so it receives light information from the eye and synchronizes our day and night cycles based on that light. So people that work at night actually have a really hard time developing that schedule because they're kind of overriding their biology. Our biology really, really relies on those night and day cycles. If you're traveling internationally, it's really good to just go to sleep at the normal bedtime on that different time zone because their suprachiasmatic nucleus will reset your body to the new time zone. If you really just make a concerted effort to go to bed on time and to wake up on time, the whole thing will reset. And it does all of this by stimulating the locus coeruleus, which releases norepinephrine and kind of wakes everything up. So biological clock, it's in the hypothalamus, so it's involved in a lot of the hormone transmission stuff, but it uses norepinephrine through the hypothalamus to kind of wake everything up and to set those day and night cycles. So I wanted to bring up sleep to kind of set up the next slide. So sleep is really important when you're thinking about consciousness because we spend half of our lives not conscious. We're kind of unconscious for half of our lives. And throughout that sleep cycle, we're kind of transitioning between non-REM sleep and REM sleep. So non-REM sleep, these brain waves have kind of a higher amplitude and are less frequent. So that's kind of this right here. It's believed that there's a lot of kind of maintaining stuff going on and like repair and things going on when we're in these deep sleep states. And they become a lot less deep the longer we sleep. So the closer we get to waking up, the further out of these cycles we get. But then we also go into REM states where the brain waves have lower amplitude and are more frequent, and they look a lot like awake patterns. And this is believed to be something that's contributing to like memory consolidation and things like that. The important thing that I wanted to note here was that when we're in REM sleep, we have a complete loss of muscle tone. So we're essentially paralyzed when we're dreaming. And this is really important because our brain doesn't want our body to act out whatever we're doing in our dreams while we're consolidating all those memories and things like that. And I wanted to bring that up because of the disorder of sleepwalking, also called somnambulism. And somnambulism, the reason I wanted to bring it up is because it's really interesting when you're thinking about consciousness and when you're thinking about whether or not we should be held accountable for some of the things that we do that we're not necessarily conscious of. So they've done EEG and imaging studies on people that suffer from sleepwalking, and they show that cerebellum, the posterior cingulate cortex, which kind of monitors different functions, and the brainstem are active while they're sleepwalking. But the cortex, the anterior cingulate cortex, things that are involved in like cognitive control and emotional regulation, are asleep during this time. So you have these things that are able to get the body up and moving and functioning, but you don't have anything online that's actually involved in like cognitive control type stuff or regulating any of those emotions or those decisions or anything like that. And the reason I bring this up is because there was this man who he had gotten into some gambling trouble, and he was really anxious, hadn't been sleeping really well, and he was needing to tell his wife about it and his in-laws, who he had a really good relationship with. He was really worried about kind of revealing all of this stuff to them, and he hadn't been sleeping well. And one day he woke up and he was just kind of like, I think he was in his room or somewhere, and his hands and arms and shirt and everything were covered in blood. And he went immediately to the police station, turned himself in and said, "I think I've done something wrong and I don't know what." It turns out that he actually killed his in-laws. He got in his car, he drove all the way to their house and killed them both, and then drove all the way home and then woke up. And you can kind of come to conclusions yourself about this, but he was acquitted by a jury who believed that he was actually sleepwalking. They put him in sleep labs and discovered that he had a family history of sleepwalking and that he engaged in very intense sleepwalking type activities while he was under observation. The police officers didn't really discover any motive or ill will towards the people that he ended up killing. And he was extremely regretful about doing it and just didn't understand. He turned himself in immediately. And it's just really interesting because this whole jury, this 12 people, ended up giving him a non-guilty plea and said that he was not responsible for those actions. And so does consciousness have to be involved for us to be held accountable for what we're doing? I've brought this up a couple of times throughout the class. There are a lot of things that we do that we don't necessarily have control over. And it's an interesting thought experiment. I know that this is a really extreme example, but it really makes you think about some of these things and really think about the way that we punish people in this country and hold them accountable. It could be that we just need to rehabilitate and not necessarily punish, but that's definitely up for debate. I think that neuroscience can definitely weigh in on a lot of those things, though. And there are a lot of researchers that are pursuing neuroscience and law type degrees, which can be really interesting as we start to work some of this stuff out. So we'll get into complex systems. What a complex system is. So complex systems are things that have a lot of interacting parts and have some type of kind of emergent behavior. So conscious awareness has these vast amounts of mental processing that happen outside of conscious awareness, as we've kind of hinted at throughout the lecture. We're only aware of the contents, but not what generates them, right? We're not aware of the actual neuronal activity. We're just aware of what those neurons actually produce. And it's really important to kind of consider how these non-conscious and conscious processes are interacting. And we have this kind of framework from complex system theories that really try to explain how this is happening. So complex system involves a large number of interconnected and interacting components. And so we look at the brain is very much like this. We have tons of individual neurons and individual components out down here that are kind of dynamically interacting with one another, that are forming these kind of networks, these modules that are then interacting with one another, and form kind of at the top end of this really complex system of systems within systems. So some of these components are predictable, but most of them are not. We can't really understand what an individual neuron is going to do. And learning about the parts only gets you so far. You can learn about what the neuron does, but that doesn't tell you how this whole thing works up at the top. So we really have to spend a lot of time looking at this organizational structure and seeing what this organization really tells us about. Because if you look at any part in isolation, it doesn't tell you about the overall function. And if you just look at a function, you can't really make any inference about what created it. This is kind of inherent in complex systems in general. Societies are complex systems. And these complex systems have what's called a layered architecture. So the brain is really highly organized. The organization takes a lot of things into account, like how much energy it's going to cost to do certain things, how much space there is based on the size of the skull and the size of the brain. And it doesn't come about, this complexity is not kind of by accident. The system itself is trying to become more efficient and more effective and more reliable. And so when it faces problems, it becomes robust when specific layers are kind of assigned to address specific types of problems. And we've talked a lot about this through this course. There's certain brain regions that handle very specific types of information. And no added feature, so no individual module is robust to all events. They each have their own kind of fragility. So that each module can't handle every kind of information. And so you end up having to need different parts of the brain that handle different parts of information that kind of evolve to make that whole thing more efficient. And once one of them fails, that's kind of what gives rise to a new one coming about. And they think that this is kind of how the brain has evolved. And so you kind of see this layered architecture over here. You have the outside external world down here. You have things that are being sensed, and you have these needs that the self already has. All of these things are kind of interacting with each other up these different complex layers as you go up. And as we form perceptions, those perceptions are put into memories. Those memories can be drawn on into short-term memory to monitor goals. Those short-term memories can be consolidated into long-term memories, and that we can have so all of this stuff. What I'm trying to get at is that all of this stuff is kind of this layered approach where you have one layer is passing information to the next, which is passing information to the next, and that they're all kind of interacting with one another in a very complex way. And all of this processing is happening in parallel. It's happening simultaneously. This is something that we've talked about. So like when we're looking at something that's moving, there's one part of our brain that's processing the motion and another part that's processing the color of the thing that's moving. And both of those things are happening at the exact same time. And the information from those modules is then being passed up to conscious awareness. So we have this idea that we have this system of systems. And each of the different ones that we've talked about, so the attention system, the motion system, the perception or object recognition system, each of those systems has its own set of layers that end up contributing to the overall content that it sends to conscious awareness. And a single layer can kind of be just its own little module, or it can also be kind of a group of modules that are all working together to produce some type of output. And each of these layers kind of has its own specific protocol, its own rules that allow for specific types of information and how that information should be processed. And so you have all of these inputs that come into a certain brain region. That brain region is supposed to process color, say, and then it outputs that color to these other layers that are then going to do something different with that color to create the complex perceptions that we have. And as you move from one layer to another, so the processing kind of occurs up this stack of layers, right? Where you have the output from one layer is passing to the next one, which is passing to the next one, which is passing to the next one. And the layer above only knows how to deal with a certain kind of information, a certain kind of protocol. That protocol may be similar to what happened in the last one, but it's unique. And that layer doesn't actually know what the input was to the previous layer. It's just passed processed information, and then it does what it needs to do to that information and then passes it on to the next layer. So this layer doesn't have any idea that this layer even exists, because this one passes information to here, this one passes information to here, and it just kind of gets passed up until at the very top it's passed to conscious awareness. And so it's this idea that the processing of each layer is hidden from the next one. All the next layer gets is the output from the one below it. And this is this idea of abstraction. So each layer kind of works on this need-to-know basis and just processes the information that it's familiar with, that it needs to deal with. And so when you're interfacing with a complex system, so a smartphone is a complex system, and whoever the user is only dealing with the very topmost layer. So the person that's using that smartphone doesn't have to know all of the gadgets and things that are inside that are making all of that processing possible. All it needs to know is that there's an icon that says home that they can click on. That's the information that has been provided to them. The brain does the exact same thing. There's a ton of stuff in the brain that is producing the perception of home. And the user, us, consciousness, then has access to that information. And you don't have to know how your brain works to use it, right? We have for thousands of years, humans have been using their brain without even knowing they had a brain. Greek philosophers, all these kind of people that didn't know how any of this worked, were still able to use the output from all of these layers in this complex system. But one of the issues that a lot of neuroscientists run into is this idea of multiple realizability, that there's a ton of different ways for a system to produce the same behavior. And this is something that's really, really tough for neuroscientists that have this kind of reductionist view of if we can understand how the neurons work, we can understand how the system works. They might be able to tell us how the brain can work, but they can't kind of reveal the whole story by just studying the individual parts. So we really need to kind of approach it from this layer perspective and understand more of the organization and what each layer is contributing. And there was this whole idea from connectome work that kind of gets at this multiple realizability problem, So this team ended up mapping out the entire neural network of a lobster. So every single synapse in this entire lobster's brain. And they wanted to know what kind of network or what region of neurons or whatever was contributing to this gut activity, this pyloric sphincter activity or whatever. And they found that there were 20 million possible network combinations overall in the entire brain. And when they really looked into it, they saw that 1 to 2% of all of those different possible combinations of synapses still produced the same gut reflex. So 1 to 2% seems like a really small number, but it's 1 to 200,000 different combinations of different synapses all firing in a specific way, all produce the exact same behavior. This is what I meant by multiple realizability, that different neurons can produce the same behavior. So just by understanding the individual parts, you can't really understand the overall behavior. And so this was these normal pyloric rhythms that I was hinting at could be produced by a bunch of different cellular and synaptic properties. And so it really makes this whole idea of understanding the complex system hard, and really makes us realize that we need to look at the organization and we need to look at the layers and how the layers interact with one another to really understand how it works. So we'll end the lecture by getting into access to information. So we'll look at things that people have access to but are not conscious of, and what that says about consciousness. So one of these ideas is blindsight. So some people that are suffering from this lesion in the visual cortex, they can respond to a stimuli without actually being able to say that they can see it. So it kind of happens outside the realm of consciousness. So this person may have a lesion back here where the apple is, and he can report that there's something there, but can't actually see it. And they'll deny that they're actually able to do the task. They're like, there's no way that I'm doing this correctly. But they're way above chance when they're doing this stuff. So the brain has access to something, it's just not revealing it to conscious awareness. And we've seen this, we talked about neglect with when we got into attention, and this was a very similar thing. So these people, they have fully functioning primary cortices, so the part of the brain that's actually processing the information in that part of the visual field that they can't see, but they can't report on it. They can't actually tell you that they're seeing something. Their conscious awareness hasn't been given access to it. But if you ask them if there's two images are the same that you're showing them, they can tell you that they're not. Even though they can't actually see one of them, they can tell you that they're not the same object. And so it's this idea that the brain still has this information, it's just not passing it all the way through. And so when you think about this from kind of a layered perspective, the layers that are doing the actual perceptual processing are still working. They're still processing that there's an apple here, but then they're passing it to another layer that's kind of a control module that's supposed to then pass that to conscious awareness. And that control module has been deleted. They've lost this chunk of the parietal cortex. And so that portion, that layer that's supposed to pass something to conscious awareness just isn't there. And so it's still been processed, but the way that it gets to consciousness has been impaired. So just kind of an interesting example of how you really need to have the information get all the way to the top for consciousness to be aware of it. And they've looked at this with subliminal perception as well. So if you flash a bunch of items really, really fast, a person's going to say that they don't know what they just saw. And they did this where they flashed a bunch of images, and one of the images was this little girl that was about to throw a cake at you. And another group of participants didn't see this one. Instead, they saw this one, where it was this girl that was just really nice, kind of handing this cake to somebody. And they both said that they couldn't see it. They didn't know that they had seen a little girl with a cake. And later they were shown this picture. And they asked them to make personality judgments about what this little girl is like. And it was completely biased by which of these they had seen subliminally. So if they'd seen this one, then they thought that this girl was mischievous and that she was a troublemaker. And if they saw this one, they thought that she was like this sweet little girl that was about to give them a cake or whatever. So really kind of another example of information that hasn't really made it to awareness, hasn't made it to consciousness, but is still somewhat affecting the overall behavior of the organism. This was just kind of a convergent evidence thing. So same idea, they showed subliminally all of these different images, and then they gave them these incomplete words, and they told them to fill out the rest of the word. And so the subjects said that they didn't see anything. I don't remember seeing a kangaroo. Well, this one, they did see a kangaroo because it was presented for a really long time. But like with the bike, they never saw the bike. They don't report seeing a bike, but then they'll still fill this word out as being bicycle. And so it's this idea that they've been primed subliminally, and then that's kind of biasing their conscious decisions. And so there's something being processed in these lower layers that's then kind of influencing the way that they behave and the way that they make decisions. So, and that was just what I was getting at. So it's being processed at kind of a lower layer, and it's being passed to the conscious layers without the person really being aware that it's happened. So there's a lot more to consciousness. I really kind of implore you to read the rest of the chapter. This got through about half of it, but we're going to do a couple more things. Sorry. So this was something that came out of the motor literature. So there's this whole process of switching from conscious to non-conscious layers. And a lot of the work that's been done is looked at motor tasks, right? And we talked about this when we were getting into the motor lectures, that there's parts of motor control that are very habitual and very automatic. And there are other parts that are more cognitively controlled. And these researchers, this was Rochelle and Peterson, the people that actually discovered imaging, really started to get into this. They noticed that there was, when they were learning or practicing a skill, there was a ton of conscious processing happening, that they were kind of scaffolding how to do this task while they were practicing it. Memories being consolidated, the skills being kind of honed. But they noticed that as the people got better at these tasks, after they learned the task, the brain activity started to change, and it started to pass to these kind of lower subcortical type areas. So I'm going to go through these last couple of slides real quick because I think I'm running out of time. So they studied chess players that had progressed from novice to master. And the masters were really good at playing lightning chess. They could play a ton of different games at the same time really quickly without really ever knowing how they knew what the next best move was. They just kind of knew it. Oh, my wife is walking in the door. Give me 1 second. All right, sorry about that. So what they were doing with these chess players, they looked at novice chess players and master chess players, and the masters could play really, really fast, and they didn't really know how they knew what the next best move was. It was just kind of habitual, and they just went with it. Whereas these novices had lightning play was really, really hard for them. They couldn't do it because they were actively thinking about how every move needed to happen. It was this very conscious process. So these master players, the activity is believed to have been kind of passed to the non-conscious layers, so that they're able to just do all of these things without even thinking about it because they know the game so well. Whereas these people were practicing, they were trying to create those habitual actions and those ideas of how to get through the game without having to think about it. And they took one of these chess players, this guy Patrick Wolf, he was a grand champ. He beat Nikola, I can't remember his name, Russian guy that was grand champ for a long time. And they were studying him, and they showed him a chessboard, and they took the chessboard away after a short period of time, and they asked him to put all the pieces back in the same order that they were in when he had seen it. And when they did that, he got 25 out of the 27 pieces right. And to put this in perspective, the controls only got 5 of them right. So this was like incredible that he was able to do this. But if the position of the pieces didn't make sense, chess sense, if they weren't in places that the pieces should have been in, if it was a real chess game, his ability fell to all the way at what the controls had been. And so it showed that there was this conscious kind of, or this unconscious representation of the game, of the pieces and all of that thing, all of those things that have kind of influenced his conscious awareness and his ability to do the things that he did. So there's a cool YouTube video here. You can check it out and kind of see how he did what he did. I'll end with this last slide about how people kind of think that consciousness has evolved and what its purpose has been. And they think that cognitive control mechanisms are a big part of what it means to be conscious. And that as these mechanisms disengage, kind of the non-conscious habitual type processing just kind of takes over. And the processing itself is kind of moved to this lower layer that you as an agent, you as a conscious observer don't really have access to anymore. You're just doing things because you know how to do them. And it allows kind of this non-conscious processing to happen kind of under the surface so that consciousness can kind of be directed towards new things that are maybe more important than things that we've already learned how to do. And so they really believe that consciousness has kind of evolved in this capacity to try to improve the efficiency of non-conscious processing, to modulate it, to adapt it so that it fits the current situation or the current scenario or whatever you want to say. And so it's this ability to relegate these tasks and memories and everything to non-conscious stuff so that we can kind of devote these limited resources that we have to really adapting ourselves to these novel situations. My kind of 2 cents on this is I really think that consciousness is kind of this governmental control mechanism that really kind of chooses where resources are being allocated and what we're doing as far as controlling our body and seeking resources and all of these kind of things. And that it allows us to make decisions about how to better ourselves and how to further ourselves in the pursuit of our goals, our intentions, all of those kind of things. So that's my 2 cents. That is kind of the end of the course. I hope you guys have really enjoyed the material. Like I